Two parabolas y square equal to 4x and x square equal to 4y are dividing the square region bounded by axis with x equal to 4 and y equal to 4. And these divided portions are numbered S1, S2 and S3 from top to bottom. We need to find the ratio of the three regions S1 area is to S2 area is to S3 area. First, let's try to see how are the regions S1, S2 and S3 graphically. Let's consider the Cartesian plane. Now, how will be the curve y square equal to 4x? It's a parabola passing through origin, open towards the right? So this is our curve y square equal to 4x. Then, how will be the curve x square equal to 4y? It is also a parabola passing through origin and open upwards. And clearly these two curves y square equal to 4x. Now this is the curve x square equal to 4y. Now if you look at these two curves y square equal to 4x and x square equal to 4y would divide at the point say a4 comma 4, right? This point satisfies both the curves. Now what is the square formed? It is a square formed by x equal to 4 and y equal to 4. So what do we mean by that? This line x equal to 4 is a line parallel to y axis. So this is the line x equal to 4. And how will be the line y equal to 4? Yes, it's a line passing through 4 comma 4 parallel to x axis. This is y equal to 4. So these two curves y square equal to 4x and x square equal to 4y are dividing the square region into three parts, and these parts are numbered from top to bottom as this portion is S1, this region is S2 and this region is S3. Now we need the ratio of these regions. So before we find the ratio of these regions, first let us calculate the area covered by S1, S2 and S3. Clearly S3 will be the region area bounded by which curves are binding this area? Y-axis and the line x equal to 4 by the curve x square equal to 4y. So it is area bounded by x square equal to 4y with x equal to 0 and x equal to 4 with x-axis, right? Now we know the curve and the limitations of integration as well as bounded with x-axis. So can we calculate this area? It is integral from 0 to 4 f of x, that is x square by 4 dx, right? That is nothing but 1 by 4 times x cube by 3 between the limits 0 to 4, which is on calculation is 16 by 3 square units. Now we are able to identify the area of the region S3. Now if you look at this curve, S2 plus S3 will be the region bounded by y square equal to 4ax with y-axis and the line x equal to 4, that includes S3 also. So can we rewrite now S2 plus S3 is the area bounded by which curve? Yes, this is the curve now. That means y equal to 2 root x, because we are talking only in the first quadrant, by y-axis, that is x equal to 0 and again x equal to 4 with x-axis. Now we know that S3 value is already known to us. So this value of S2 plus S3 would be equal to, how much is the area bounded by this? This is from integral 0 to 4. The area bounded by f of x, that is 2 root x dx. This can be evaluated clearly by 2 times x to the power of 3 by 2 by 3 by 2 evaluated between the limits 0 to 4. That is 2 times 4 to the power of 3 by 2 by 3 by 2. That is 16 by 3. So this is coming to be 32 by 3 square units. But out of this we know the value of S3. So can we calculate S2? S2 would be 32 by 3 minus of 16 by 3. Now 32 by 3 is the area bounded by the parabola y square equal to 4x and 16 by 3 is the area of the region S3. So this would be now 16 by 3 square units. So how much is the area of the middle region? The region S2 is making an area of 16 by 3 again. Now what is left? We need to evaluate S1. Now if you look at S1 plus S2 plus S3, this total would be the area of square formed by coordinate axis. That means x equal to 0, y equal to 0 and the lines x equal to 4 and y equal to 4, right? That's a square having side 4 units. So this is 4 into 4. That would be 16 square units. Now out of this we know the value of S3 and S2. So can we calculate S1 now? S1 would be 16 minus of S2 minus S3, and we know both the values S2 and S3. That is 16 minus 16 by 3 minus 16 by 3, which is again 16 by 3 square units. So this gives us the area of the region S1 also. So our requirement is now S1 is 2, S2 is 2, S3, that is 16 by 3 is 2, 16 by 3 is 2, 16 by 3, or in turn it is 1 is to 1 is to 1. Let's verify which option mostly suits this value which we got. Yes, the option presented C, which says the required area is 1 is to 1 is to 1, right?